Good day, everybody. Welcome to my course on pipeline bend thinning calculation. You might be aware that specifically for pipeline system, whenever a cold bend is made, either mostly at site, means construction site, during bending, there could be a possibility that the thickness of the pipe in the bend region reduces. So this situation is known as bend thinning. Here in this image you can see that this is a pipe, and whenever it is bent in a bending machine, two types of force acts in the bend. One is known as tensile force or tension force, and other is known as compression force. Now towards the top side of the neutral axis, the force that is getting exerted is tension force, whereas towards the bottom of the straight pipe, it will be a compressive force. So the top part will elongate and the bottom part will compress. Now due to this elongation, the pipeline thickness will be reducing, and we have to perform a calculation known as pipeline bend thinning calculation to ensure that after bend thinning also the thickness available is acceptable from design integrity point of view. So that is the main reason we have to perform pipeline bend thinning calculation during design phase to ascertain that the pipeline will be able to sustain the internal design pressure, and also at the same time it will work satisfactorily, performing its intended action throughout the design life period. Now the main topics that I will be covering in this course are: first, an introduction; then what is a pipe bend and what are the main differences between a bend and an elbow. Next, I will be explaining what is pipeline bend thinning, what is the actual meaning of bend thinning, then why is bend thinning calculation required. Next, what are the steps for bend thinning calculation and key parameters that affect the bend thinning calculation. And finally, we will see a practical bend thinning calculation example. Now, before proceeding for this course further, let's understand who is this course for, means who should be the ideal candidates who should undertake this course. So from the title itself, you can understand the course is related for pipeline professionals. So the course will be ideal for pipeline design engineers, means engineers involved in the mechanical design and stress analysis of onshore or offshore pipeline systems. Next, stress and flexibility engineers, engineers who perform stress analysis using tools like scissor 2, autopipe, start prof, row 2, etc. Then fabrication and manufacturing engineers, these are the professionals working in pipe bending shops or fabrication yards. Then QA/QC and inspection engineers, the engineers responsible for quality control, inspection and testing of pipeline components. Then pipeline construction engineers, engineers involved in the field bending or installation of pipelines. Then maintenance and integrity engineers, engineers working on pipeline integrity management or fitness for service assessments. Next, project engineers, managers, those overseeing pipeline EPC or EPCM projects. And finally, students and researchers who are final year or post-graduation students in mechanical, civil or pipeline engineering. They also will be able to understand the basics of pipeline bend thinning if they undertook this course. Now, what is a pipe bend? Pipe bends can be defined as a custom fabricated component and can have larger, smoother radius or radii, making them suitable for high pressure pipelines, long distance transmission lines, or systems carrying fluids at high velocities. In simple terms, a pipe bend is a curved section or portion of a pipeline that redirects the flow smoothly from one direction to another without causing sharp turns or turbulence. So, a pipe bend can be defined as a curved section of pipe used to change the direction of flow in a piping or pipeline system. In this image, you can see some typical pipe bends. Now, what are the purpose of a pipe bend? To, the main purpose is to change the flow direction, to absorb thermal expansion or ground movements in pipelines, to reduce pressure loss and flow disturbance compared to elbows, to fit pipeline routing around obstacles such as roads, rivers, or structures. Now, what are the types of pipe bends? Type bends, pipe bends can be classified as cold bend, means formed at room temperature using mechanical or hydraulic bending machines common in onshore pipelines. Then hot bends, pipe is heated before bending to reduce material stress. Next is induction bend, a precise method where the pipe section is locally heated by an induction coil while being bent, widely used in modern pipeline construction. Then one type of bend is known as miter bend, made by cutting and welding straight pipe pieces at angles used for large diameters or non-standard bends. Now, in every pipe bend, an important term is pipeline bend radius. What is that? It is defined as the radius of curvature of the bend's center line. So, for example, if there is a neutral axis or center axis through this bend, then the radius of that center line can be defined as the bend radius. This is expressed as a multiple of pipe diameters d. For example, a pipe bend or pipeline bend can be 20d or 30d, means 30 times of diameter. Larger bend radii help to reduce flow resistance and stress concentration. Commonly used pipe bending methods are rotary die bending, rollers bending, hydraulic bending, incremental bending, conduit bending, etc. So by now, I believe that you have a clear idea of what is a pipe bend. Now, what are the major differences or main differences between a bend and a elbow? Now, based on several aspects, I have listed down the main differences between a pipe bend and pipe elbow. So, a pipe bend is a curved section of pipe used to change direction, usually fabricated by bending a straight pipe. Whereas pipe elbow is a prefabricated pipe fitting used to change flow direction at a specific angle, commonly 45 degree or 90 degree. Manufacturing method: made by cold bending, hot bending or induction bending of a straight pipe, whereas pipe elbows are factory made fittings, usually cast or forged and as per standard like ASME B16.9. Bend radius typically larger, such as 3D, 5D, 10D. These are for hot bends, and more than 20D is usually for cold bends. While pipe elbows are usually shorter, short radius elbows are usually 1D and long radius elbows are 1.5D. Then flow characteristics: provides smooth change in direction, causing less pressure drop and turbulence, whereas in a pipe elbow, sharper turn causes more flow resistance and higher pressure drop. Then applications: used in pipelines, process plants and long distance flow lines where smooth flow and flexibility are required, whereas piping elbows are common in compact piping systems, that is plants, refineries where space is limited. Fabrication flexibility can be made to any angle or radius as per design requirement. This is available only in standard angles, typically 45 degree, 90 degree and sometimes 180 degree. The standard usually fabricated as per project or client specification. Sometimes it may be designed based on API, DNV or ASME B31 standards. However, piping elbows are usually manufactured based on ASME B16.9 standards. Cost: generally more expensive due to custom fabrication and inspection requirements. Pipe elbows are standard items and usually cheaper and readily available in standard sizes. Thickness variation: may experience wall thinning at extrados and thickening at intrados during bending, whereas piping elbow has uniform wall thickness as it's factory made. So I believe you now know what are the major differences between a piping bend as well as piping elbow. Now pipeline bend terminologies. There are various terminologies that are used to understand or to inform a pipeline bend. So before jumping into the pipeline bend thinning details, let's learn about the important terminologies of a pipe bend. First is, you see here DOB or arc that is mentioned, that is degree of bend. Then WT is the wall thickness. Then ISR is the inside radius and OSR is the outside radius. These are normal references defining the extreme inner and outer limits of the arc. The CLR is the center line radius, of course the average of the ISR and OSR. Then plane of bend is the plane defined by the inside radius and outside radius. Line of tangency is actually a plane perpendicular to the plane of bend, passing through the origin of the bend and the beginning point of the bend. In other words, it separates the arc of the bend from the tangent section. Before the line of tangency, the tube is straight. Past the line of tangency, it is bent. In draw bending, the line of tangency is fixed in space through which the tube or pipeline is drawn around the bent die as it rotates. Neutral axis versus center line radius CLR. As shown in this figure, the neutral axis is physically close to the center line radius, but these terms are not synonymous. The neutral axis is a narrow region lying inside of the central line radius, separating the zone of compression from the zone of stretching. At the neutral axis, the tube wall neither compresses nor stretches. Now when a bending action is performed, as I already mentioned in the first slide, that the outside radius gets stretched, whereas the inside radius it gets compressed. However, at the neutral axis there will not be any compression or elongation. That is the reason it is known as neutral axis. Now, definition of pipeline bend thinning. I already explained in the first one that during bending action, the outside radius or adjacent part from the neutral axis towards the upper side gets elongated, and because of this elongation the thickness reduces to some extent. That reduction in thickness of the pipeline bend is known as bend thinning. So towards the tension force area bend thinning happens, whereas in the compression part area bend thickening happens. Similar details are again explained here. You can see that this is the central line radius, this is intrados, inside bend radius, and the outside is extrados or outside bend radius. This is the neutral axis, this is the tangent length, this is the wall thickness, this is the tangent point transition area. Beyond this point the pipeline bend starts, whereas towards the right side this is the straight part of the pipe. Here this is the DO or outside pipe diameter, this is the ID or inside diameter, and this is the wall thickness. Hope all the terms are clear. Now what is pipeline bend thinning? Pipeline bend thinning refers to the reduction in wall thickness that occurs in a pipe bend during the bending or forming process. You see in this image that how the pipeline is being bent. So when uh, this part is straight and this part is pulled with respect to the bend radius, and when it is pulled due to the elongation in the outer surface of the pipe, there is a reduction in wall thickness which is known as pipeline bend thinning. It is a key consideration in pipeline design and fabrication because excessive thinning can weaken the pipe, making it more prone to failure under pressure or stress. That is the reason we should perform bend thinning calculation. So that's all for the introduction module. Hope you got a clear idea of what is a pipeline bend, what are the main differences between a pipeline bend and a piping elbow, what is the meaning of pipeline bend thinning, what are the terminologies or terms associated with pipeline bend, and why should we perform pipeline bend thinning calculation. So this is the end of module 1. Now we will meet again in module 2. Thank you. Happy learning.